Hi, everyone. Welcome to this session from Test Kitchen to Table, a demo-driven tour of Foundry portal for AI developers. I'm Carlotta Castelluccio. I'm a senior AI advocate at Microsoft, and I'm here with Nitya. Hi, Nitya. How are you doing?
Hi, Carlotta. So exciting to be at Build again. Hi, everyone. My name is Nitya Narasimhan. I'm also a senior AI advocate on the developer relations team at Microsoft. And we're both here really excited to talk to you about Microsoft Foundry and specifically about Portal. Where does your journey start? Every AI development journey has to start with a business scenario. In our case, we're going to talk about a retailer called Zava. Zava is a fictitious enterprise retailer selling home improvement goods to DIY project enthusiasts. And you are part of the AI development team. You are tasked to build Cora, an AI shopping assistant that can answer customer questions in-store or online and provide customer service. Now, you want to design Cora to be friendly, helpful, and cost-effective to deploy. But you also understand that in this fast-paced environment, your agent needs to keep adapting to changing conditions, changing systems, and changing needs. So what do? Well, let's start first by understanding what AI app development looks like. So at a very basic level, an AI app is nothing but a model that takes an incoming prompt, does some processing on it, and generates a response. And that response can then be used to trigger other actions, which in turn might generate new prompts, and so on, and the cycle continues. And that's at a very, very basic level. You can think of this as a monolithic application where in order for that model to generate that response, there's other things that happened to coordinate it. But when we think about scale level delivery, it becomes more complicated. Now you have multiple models, multiple prompts, multiple conversations, and you need to coordinate and orchestrate all these together. Plus, now you need to extract information from all these conversations at scale to determine what you need to do next. And that is a challenge. So traditional AI application that's monolithic can't really do this in a very agile way. This is where agents can help. Agentic AI brings a microservices-based approach where every agent is a single unit of work that can be evolved independently without having to rewrite the entire system. What that means is now when you have a giant application, you can just go in and update or evolve individual agents without having to think about how the entire application has to be redeployed. But to do this, you need a repeatable and simple way. And what we want to do is talk to you about an analogy. You need a test kitchen where you can quickly prototype out these little agents before you put them into production. And that's the analogy we're using today. How do you go from test kitchen to table? Think about your AI application as, or your AI solution as the equivalent of a multi-course dinner menu at a very popular restaurant. You don't go around designing your recipes right at the dinner table. Rather, great chefs will have a test kitchen where they quickly experiment with these recipes until they get something that passes their taste test or evaluation. Then they can take those and move it into their restaurant kitchen or code-first development environment to make that better. Today, we're going to see how Microsoft Foundry Portal is your test kitchen. You can go rapidly from a plan to a basic prototype till your recipe works without writing a single line of code all in your browser. So what can Foundry do for you? Let's think about it in terms of 3 developer needs that we meet. First, when building these agents in a microservices approach, we need to rapidly prototype, build, and deploy them so we can actually have real customers try them out. Next, we understand that things will change. Models may change. Your prompt requirements may change. Your situation, the environment you're in may change. We need ways to do easy experimentation and evaluation to test these prompts, models, and datasets without having to reprovision each time. And last but not least, your app has to be trustworthy. We need mechanisms for secure, scalable, and production-ready development. And that means having a unified end-to-end platform that provides all these capabilities for us. So I want to hand off to my colleague to see how we go about actually building this. Carlotta?
Yeah, thanks, Nitya. So yes, let's go deeper into how Microsoft Foundry can help you in this end-to-end journey that Nitya kind of introduced to us, and how is able to address the developer needs we have just seen. So first of all, Microsoft Foundry, you can orchestrate a multi-agent system with support of both interoperability and also open frameworks. You can also access to the best foundational and open source models in the model catalog, and select find a model which is the best fit for your use case. You can connect your AI apps and agents to different knowledge sources and tools using also built-in features in order to contextualize AI responses and enable AI to take actions on behalf of the user. You can continuously evaluate your solution through every stage of the AI development lifecycle with proper content safety and security measures included in every layer of your AI app or your AI agent. Also, AI apps and agents should be tuned and customized continuously to fit the business needs. And finally, you need the ability to deploy anywhere you want, including to local and edge devices. Now, we're not going to see everything, of course, in this session, but at least most of it. The green points you see in these visuals, so models, knowledge and tools, and observability, we're going to fully cover it with our hands-on demo in a few. And we're going to briefly touch on deployment as well. Now, basically, all you need to get started is what Nitya called a test kitchen, where you can try out various recipes to build new and optimize existing AI agents before deploying them into production. And our test kitchen is the Microsoft Foundry portal. Now, the Microsoft Foundry portal provides a low-code solution to this problem. Within the Microsoft Foundry portal, you can experiment with models, tools, and instructions for a single agent in a browser-based playground before even writing a single line of code. You can use built-in support for observability. We are going to see traces, evaluations, monitoring features to accelerate the inner-outer loop transitions, iterating quickly and deploying versions that can be compared in real time. You can then move seamlessly to code-first environments to transition to multi-agent solution or develop further customization and use maybe more complex frameworks and workflows. So you basically move from the test kitchen to the restaurant. And it's never been easier to build, optimize, and govern AI apps and agents within a unified platform as Microsoft Foundry portal. Now, looking at this end-to-end developer journey, the Foundry portal has been kind of structured in a way to mimic the three main phases of this AI development journey. So for each step, you have the features and the tools you need to go through them. So in the design phase, you identify the business use case, you do model exploration, you test your domain prompts over different models for comparison, and you build your agent prototype by equipping it with the right tools and knowledge. While you do that, you should make sure to have a robust tracing system so you can debug your system, inspect any issues, and address them with further fine-tuning and customization. Once you've got your prototype ready, you then can optimize it further by moving into code, hosting it maybe in a dev container, evaluating the overall agent behavior, and publish it. Now, every time you complete one of these steps, like the build step or the optimize step, you should ask yourself if what you have got is ready to move to the next phase. So you're kind of satisfied with the result so far by looking at traces, looking at evaluation results, and specific metrics you define. Third step is about governance, safety, and application integration and shipping. So making sure that your application is ready for production, and you also have everything you need to monitor your any regression over time. All this process is a loop, is an iterative process, not a linear process. So you might need to go from right to left at some point because you need maybe further customization of your model or further customization of your prompts or your overall agent. You need to run evaluations once again. So again, it's a loop. It's an iterative process of continuous improvement of your application. Okay, so now let's go to the core of the session, which is our hands-on journey to build our first prototype within the Microsoft Foundry portal. So let me switch to my browser so we can go into the Microsoft Foundry portal. And specifically, our starting point from this journey will be ai.azure.com, which is how you would access the Microsoft Foundry portal, /templates, where you basically can see a bunch of solution templates for your AI apps. You can see, for example, an AI chat app, AI agent app, a multi-agent workflow. You can basically explore all these different solution templates and find the one which is closer to your specific business scenario. Because, you know, sometimes starting from scratch might be intimidating. But another option you have is simply clicking on this Start Building button here and creating your first Microsoft project, Microsoft Foundry project, which is basically your workspace within Microsoft Foundry, where you're going to create and manage all the resources relevant for your AI application. So to start, I'm going to create a new project and I'm going to give it a name. Okay, and then we go to the advanced options to configure things like the subscription, the Microsoft Foundry resource name, if you want to customize it, the region where you want to deploy your resources and your project to be in, and the name of the resource group we're going to create. Okay, let's click on the Create button and wait for a couple of minutes so our Microsoft Foundry project is set up. So the other thing we can do is we can switch to the Microsoft Azure portal. So we can look at the resource group and the resources that will be created through this UI creation project you have seen. So I keep refreshing till I get the resource group, the new resource group that has been created for my Microsoft Foundry project. Okay, that's it. So the project has been created. So now I should be able to see here my new resource group. So let's refresh the full page, the full web browser here. Okay, so by refreshing this, I will get my new resource group where the Foundry resource and Foundry project have been created. So here you can see a couple of resources, the Foundry resource and the Foundry project that has been created through the process I've completed in the Foundry portal UI. So I click Next in here. And I can see that I can look at things like the API key, the project endpoints, all the credentials I would need to connect to these resources through code. I'm going to click Next and then click on Create Agent. So to get started with my first agent prototype creation. So you can see as all this flow was very guided. I just click the Start Building button, and then I've got a guided process to create a resource group, to create a Foundry resource, to create a Foundry project, and now to create an agent. So let's just choose an agent name that in my case will be a retail-based agent. Because we are, if you recall the business scenario that Nitya described, we are building an agent for our Zava retail company. So I'm click on Create and I'll wait for my first agent to be created. And you can see in here that under the hoods, it is also deploying a model, which is GPT-4.1, which is the default model which gets created when you create a new agent. Then we are going to see that you can, of course, also deploy other models and change your model engine, your agent's model engine. Okay, here's the agent playground. So all this process led me to the agent playground within the Foundry portal. So in here, I have my retail-based agent, and I can configure all the agent's component. So I have the model, which again is the default model in this case, which is GPT-4.1. I have my default instruction, which is basically empty. I have tools, and I have a default tools, which is web search, which means basically that this default agent can access information, fresh data from the web search. But I can also, of course, customize tools. For example, I can add another built-in tool, which is code interpreter, which makes my agent also execute code in a Python sandbox environment. And then I can also browse all tools and add other built-in tools from these tool catalog. And I have also a bunch of tools exposed by MCP servers. So there's lots of built-in tools I can use, I can configure. And then there's also other properties of my agent. I have things like knowledge, so I can add different knowledge sources. I can connect to the Foundry IQ. So basically, I give my my agent access to Zava, for example, in our scenario, Zava IQ, so the knowledge of my enterprise. And then I can add memory in a way that my agent can keep a memory across different sessions for the same users. So here's basically here's the playground where I can configure all the properties, all the components of my agent. And on the right side, I also have a chat interface where I can test my first agent. Now, the other thing I want to show you is the model deployments, because as I mentioned before, my agent, in my agent creation, a new GPT-4.1 model deployment has been provisioned. And together with this GPT-4.1 model deployment, also a text embedding 3 large model instance has been provisioned. Because most of the time you're going to need to implement a RAG pattern for your agent. And so you need an embedding model to do so. But let's come back to the agent playground. And let's start by testing our agent with a very simple prompt. So let's ask our agent, what can you do? Of course, we're going to get a very, generic answer because we didn't customize at all our agent. We just customized the name, but everything else is like default. But still, we have an agent, that we can interact with and test. Now, let's try with another prompt, which is domain related at this point, which is what paint should I use for my outdoor deck? So let's recall that Zava is a retail company selling DIY products. So that's why I've asked this question. And again, what I get is a pretty generic answer, which is based on data the model has been trained on, and also data from the web, as this agent has access to the web. Now, the other thing I want to show here is I'm in the playground now, but the other thing I can do is I can debug my agent by looking into its traces. So to, double check what's happening under the hoods. And in case of issues, errors, or hallucination, I can kind of look into what's happening behind the scenes. Now, to start collecting traces for my agent, though, I need to connect to an App Insight resource, which I don't have at the moment in my resource group. So the next step will be clicking on this connect button in here, and then clicking on create a new resource. And I'm going to create a new App Insights and Log Analytics workspace resources within my resource group. Okay, so moving back to the portal, we can see in our resource group we just created that 2 new resources popped out, which are our Application Insight and our Log Analytics workspace. So this will enable us to track the agent's activity in the Microsoft Foundry portal. So back to the portal, if I go, I'm in traces again, and if I go into responses, I can see that I can see the traces of the conversation I've just had with my agent. So even if, I didn't have my application inside at the time I have conversed with my agent, those traces are not, completely lost. I can still look at them now that I have my application inside on. So things I can see here, of course, I can see the user input, I can see the user output, I can see the metadata of the input and output messages. And in case there's some, tool call, for example, I can also inspect tool calls. Now, another thing I can inspect is some evaluation scores according to specific metrics of my agent's response. But before being able to do so, we need to select the metric we need under these metrics drop-down menu. So we can evaluate our agent response according to those. And we have both accuracy metrics and safety metrics. So here I have already selected a few, like task adherence, intent resolution, coherence, relevance, and their attack. But you're going to select the ones, most valuable, most useful for your use case. So once I've selected the metrics I want to evaluate my agent responses against, then I can click again on logs and then evaluations. So I can basically see how my large language model as a judge, because of course these are AI-assisted evaluation, scored my agent response, this specific response which is selected here, against the metrics I have selected. So for example, for coherence, I have a score of 5 out of 5 with also a verbatim feedback, kind of a reasoning behind this scoring. Same for the other metrics. There are some metrics which are just pass or not pass or fail. And there are metrics like relevance, like coherence that have both have numerical scores and pass-fail threshold indication. Okay, so that's for evaluating each agent response. And this is very helpful because if any of those fail, you can basically debug your agent and understand what caused the regression, what can be improved. So it's kind of an evaluation-driven development. So you identify, you use these tools to identify a gap, either in the traces, like in the logs, or in the evaluation results. You identify the gap and you troubleshoot the gap or the issue, and you understand how to address it. Okay, so next, I'm going to show you also, there's another thing you can look at in the traces. So let's try another prompt here. Let's imagine that we want to, our Zava customer, be able to ask for weather forecasting as well. So they can basically, for example, decide when to do their DIY project, especially if is an outdoor DIY project or a painting DIY project. They can ask advice to our Zava agent to understand when is the best moment to do their DIY project. So we want to be able to provide forecasting, weather forecasting response results to our customers. So here you can see that the agent actually retrieved the information from the web. And now this time, if I go into the logs in here, I can see the tool that has been invoked to get the weather forecasting. So I can see that the tool web search has been used to retrieve the data. And I can also see, again, the metadata of the group call as well. Okay, so these are the main things you can inspect with the traces and evaluation built-in feature of your agent. So basically, without doing any further customization, but basically just using the guided process within the Foundry portal UI, I've got an agent, a working agent with a model configured, with a tool already, a pre-built tool configured that makes the agent access the web search, and so I can test my prototype within the playground. So all these things is kind of integrated in our quick start experience within the Microsoft Foundry portal. Now, the last thing I want to show you is how you can save different version of your agent. So you can do versioning, and you can compare different version of your agent and understand which one is performing better, for example. So let's do these. Let's edit the instructions. Let's customize the instructions a bit for our business scenario. So our new instructions will be: you are a friendly assistant for Zava Retail. Ask the user when they are planning to do their DIY project and which city they are in, so you can check weather and advise them when to plan their project. So this is my new instruction set. Let me save this new version in here. So here you can see that a new version has been created, v2. So the other thing is I can click on compare versions to basically go into a playground where I can compare my version 1 against my version 2 using the same prompt. So I'm going to use the same prompt I've used before. And so on the left, for my version 1 agent, I've got the generic response I've got also at the beginning. While here, since I have customized the instructions to ask for when I'm planning to do my DIY project and in which city, at this point, the agent is asking for this kind of follow-up information before giving me an advice. So I can inspect the different behavior of my agent. I can also inspect the logs on both sides and the evaluation score on both sides. So I can basically see if version 2 is improved with respect to version 1 or has regressions maybe. Okay, let's come back to the standard playground and let's do let's look at one last bit. So I have my agent prototype right now configured with a model, some customized instruction, a tool to access web search. I want to test this agent as a web app. For example, because I want to share the preview with some bug bashers, some testers of the app. So what I can do is I can click on preview and then preview agent. And what I get is exactly a web app UI of my agent that I can use to test further my application. And I can also customize a bit this UI. For example, let me go back. And let me customize a few things. So I can go on configure, and in this configuration panel, I can add a display name. For example, the display name can be Zava Retail Agent. And I can add a description. So this agent is the Zava Retail Assistant. And then I can also add a few starting prompts like, for example, the one we have used before. What's the weather like in Lecce today? And what paint should I use for my outdoor deck? So once I have configured these customized parameters, then I can click on Preview Agent. Save, yes, of course. And again, access my agent as a web app, but with the customized layout this time. So you can see here that I have the new name, I have the agent description I've added, and I have a couple of quick starter prompts that I can use to more easily test my agent. Here we go. And you can see that, of course, in this UI, I don't get any developer logs, traces, evaluation results, or anything else I see in the standard playground. So this is just to test my agent, my agent behavior as my final user will get it. Nice. So we've got our retail-based agent prototype. We tested it. We also have seen the preview. So at this point, I think we are ready to bake off some further stuff and further customization for our agent. So at this point, I'd love to hand off to my colleague Nitya to get us further in this journey.
All right, let's do this. Okay. So where did we stop? Right now, my friend Carlotta basically built the very first agent. So that's kind of like you're tasting out your recipe and making sure that it actually seems to taste okay. But is it perfect? Not yet. So in this segment, we're going to start from where she left off and iterate and improve on our agent until it passes our taste test. So how do we do that? First, you might have seen Carlotta set up the agent for preview. Well, you can do something similar and actually set it up right here to configure it. So I'm going to go ahead and configure it one more time and save that as agent version 3. So let's go ahead and we will just really quickly, we'll give it a display name. That's our description. And we'll put in 3 prompts. Now, why am I doing this? Because you'll notice that as we iterate, we want to continuously keep testing our prompts. I mean, our kind of agent iterations against the same prompts. And this helps us make that kind of effortless. So give me a second while I fix this. So you'll notice that I actually have 3 different prompts over here. And that's because our agent should be capable of doing a couple of different things. So let's go ahead and save this. I'm going to save this. Now we've got version 3. And when I have version 3, if I close this off, I need to start a new one. And there I see the retail agent. So now we know that our retail agent can answer questions about the weather. It can answer questions about Zava products. And it can answer questions about home improvement. So that's what I've got. But it's very clear that from the previous examples that it's not yet perfect. It's not talking about Zava products. And also, you might have noticed that it generated this model for us by default, which is GPT-4.1. This is a large language model that is actually really feature rich. So kind of taking the restaurant analogy, it's like getting a cordon bleu chef to come in and make the salad. You really want to get a cheaper model to do the simplest task. So how do we find the best model for the job? So before we kind of go into it, let's start fixing this thing one by one. In our next step, we're going to see how we can improve the model. So how do we do that? Now, if I go ahead and drop this down, you'll notice that it says there are a bunch of different popular models. We're using GPT-4.1. There's Model Router. We'll talk about that. There's GPT-4o, 4.1 mini, and O4. You might think to yourself, what, 3 more models? Actually, no. What you're going to do is switch over to the Discover tab. And when you go to the Discover tab, you're going to recognize that we have a ton of models, 11,000 plus models in a model catalog. So now how do you choose? Click through into the Models tab. And now we're going to look at all the models that are available. But you remember that we started with GPT-4.1. So a quick and easy way for us to figure out how is my current model stacking up to everyone else is to go ahead and compare models. And when you do that, actually, let's go to the leaderboard first. So compare models when you want to do them side by side. But first, we're going to go to the leaderboard. What the leaderboard is a feature in Microsoft Foundry that takes all the models that are in the catalog and has predetermined or created a set of charts where it's run benchmarks on them to rank how they are on different criteria like quality, safety, throughput, and benchmark costs. And so just looking at this, you get a sense of, okay, GPT-4.1 isn't here, but if I keep scrolling through it, I should see other models that are there. And I can kind of figure out which one is better or worse. And I'm not seeing GPT-4.1 yet, but that's okay. But what this does give you is a sense of among the models that are in the Foundry, which quality is better, what safety is better, etc. And if I scroll down further, I can now see all the models listed, and I can potentially find out where my model stacks in these rankings. But this still feels a little too much for me. So I can see that GPT-4.1 is right at the bottom, right? There's a better way. And let's see how that is. The easiest way for you to do this is to use what's called a trade-off chart that's in the same tab as the leaderboards. So first, I'm going to actually clear all the models so you have nothing at all in there. And then we're going to go ahead and put the default model. That was GPT-4.1. Remember, that's the one we're using. So let's see where that hangs out. It's right at the corner. And by the way, my experience may be different from yours because these kind of metrics are evaluated daily by the Foundry team based on the current models available and any updates that have happened. So it may look different each time, but what you're really seeing is the comparative difference between the different models. So here I've got a GPT-4. Let's take a model that's maybe somewhat better. I'm going to go with, let's say, GPT-5.4. Let me throw in a nano model. If that's there, I'm going to go ahead and look for something like GPT-5.4 mini, GPT-5.4 nano. I'll throw in a 4.1 mini as well, maybe an O3. Let's throw in a DeepSeek model. What do you start seeing? You start seeing how these distribute across the grid, looking at the trade-off in cost versus quality. So in other words, where I'm looking at right now is that GPT-4.1 is sitting over here, and it's actually a high cost, low quality model. So looking at this quality, I could use GPT-5.4 nano and get the same level of quality at a much lesser cost. So why am I using GPT-4.1? So you can see that we can use this to kind of get a sense for how these models stack up against each other. We can also compare quality against things like throughput and see where they stack up, or compare it against safety and see where they stack up. But what I really like to do at this point is to go over and compare the models. So rather than look at all of these, I'm like, I now think I've got a sense of it, right? Based on the comparison I saw here, I want to look at the difference between GPT-5.4 nano, maybe GPT-4.1, and let's pick one more, 4.1 mini. And let's see among those three, which one is the best, right? So I'm going to go back over here and I'm going to say, now, hey, I want to compare models now. So over here, let's go ahead and pick our default model, which is 4.1. And then I'm going to go ahead and pick that other model that looked interesting to me because it seemed like it was giving me good quality, but was fairly cheap. So that one. And we'll throw in the GPT-4 mini, 4.1 mini, just in case we're like, hey, what if, this might be better? We don't know. And now when I compare these, what this does is gives me a direct comparison between these three, right? And you see that right now, 5.4 is getting all the gold stars. It's basically outdoing 4.1 on every criteria. In other words, I'll be getting comparable quality for a much lesser cost and getting better throughput, and its safety is better than that of 4.1. Why would I not use it? How easy is it to use? Go ahead, click that and say, I want to deploy this model into my current solution. And now GPT-5.4 nano is here. So you'll notice that when I deployed this, it took me into not the agent playground, but the model playground. And I can go ahead and ask this one. You'll see that the criteria is just as you're an assistant. And I can say, what can you do, right? And so this one is the model playground, not the agent playground. But what this means is that now, and you can see, I can see that. What it means that if I now look at the deployed models in my project, I now have GPT-5.4 nano. And that means I can go back to my agent and say, hey, I don't want to use 4.1. I want to use 5.4. So we're going to go ahead and we're going to switch this over to this new deployed model. And I'm going to save it. And remember, this is version 5. And when I save it, that's version 6. So now the two models, 5 and 6, the only thing they differ in is the model they're using. Did it make a difference? Let's try it out and see. So for this, I'm going to drop it down and use the same trick Carlotta did, which is use comparisons. So on this side, we have version 6, which is the model for GPT-5.4 nano. And on this side, I'm going to switch it to version 5. And I'm going to basically click the same thing each time. I'm going to say, what's the weather in San Francisco? Let's go ask that. And you'll see both of them are doing it at the same time. And click the button. And if we're correct, let's see what this completes, and then we'll know. So note that the other side, GPT-4.1, took fewer tokens and a little less time, but its quality was less, its safety was high, and this one had full quality. Now, you might say, didn't it look cheaper that time? Depends, right? Each time, depending on the different queries that you put, this will work out cheaper in some cases. But overall, I'm like, okay, it's not too bad. Let's try one more just for the heck of it. I'm going to clear both of these and say, what paint should I use for my outdoor deck? Or let's go with a very simple thing. What tools do I need to build a kitchen island? And let's try this again. So what we're really seeing here is how easy it is for us. Remember, this is my test kitchen. I'm really able to go look at this and decide what I'm doing. Now, this is giving us a lot more information, but note that it is a cheaper model because Nano is way less expensive than 4.1. So I'm going to stick with this, but I don't like the amount of information it's giving me. I really want it to be a little bit more concise. And remember, we wanted it to be friendly. It's not really doing the things I want that are friendly. So for now, what I'm going to do is say, okay, I'm going to stick with this new model. It is cheaper, it's smaller, and it seems to be doing its job. So let's go ahead and stick with this. But now I want to actually change these instructions. I want to make this work with my data. So let's improve the agent. So we currently did improving the model. We've got a new model. Next, we're going to try to improve the instructions. But before I do, I'm going to take a little bit of a detour and show you one other model that you must know. And that is Model Router. You will remember that when we dropped this down here, we saw Model Router as a completely different Azure Foundry model. What exactly is it? So let's just take a tiny detour and go look at that, and then we're going to come back. Model Router is an intelligent router. And what it does is it allows you to effectively not have to worry about what the model is. You just put Model Router. It looks and feels just like any other model. You send your prompt, and it will figure out the right model on the back end to send this to. So I want to really just quickly show you what this is and why that might be another good tool for your test kitchen. So over here, I'm going to go ahead and say, hey, I actually want to deploy Model Router. So I'm going to go into the model side. So we can go back to Discover, or we can do it here too. Let's go into Discover. We're going to go into Models. And we're going to look for Model Router. So over here, when I deploy this, I'm going to go ahead and say, please go ahead and deploy it here. Right now, I've not attached it to any agents. So it's going to set up the Model Router for me. And one of the things you'll notice is that, remember, this is the model playground. Whenever I deploy model and take to the playground, I can actually save that as an agent and get a new agent. So I'm just going to call this the auto routing agent. Just so, we can kind of take a look at what it's doing. And the interesting thing that you have to understand here is, in the original case, we started with a single model. We compared it, figured out a good model based on quality and cost, and we replaced it. But we were looking at just one or two use cases, simple questions. In the real world, I might have tons of different kinds of questions of different layers of complexity. How do I know the right model for the job? I can sit there and test each one using the leaderboard. Or I can deploy Model Router and have it show me which models are being used. And that's what we're going to try to do here. So the first thing I'm going to do is I'm actually going to go back to our retail base agent, and I'm going to take the same instructions. I'll put it into this new one, but we're going to do a really simple thing here. We're going to save that. And now we're going to keep asking it a lot of prompts with higher levels of complexity. So the very first one, we can ask a very simple question like, hey, what is the weather? What is the capital of France? Okay, very simple question. So Model Router will try to figure out the right model for the job and actually send me the response back. And it came up with, hey, this is a very trivial question. GPT Mini is good enough, right? So it sends it there. Then I can say, I want to build a patio during summer for a family of 5 with plants that grow. Anything like this, right? draw me up a plan of action. So now I've given it a much more complicated task, right? I'm not just saying, hey, what does Zava have? I'm saying, draw me up a plan of how I do this. This is the kind of thing that would require a higher performance model to reason and give me back a response. Let's see what model router does. Remember, though, that throughout this, I never changed the route. I never changed my model. I had a single model, but it routed to GPT-5 mini the first time. And let's see what it routes to this time when it gives us back our response. Awesome. So you can see that this time it took a lot more time, but it came back with a fairly comprehensive plan. Let's see what model it used. It's still going. Now, this is not just like a quick answer. It's a fairly comprehensive minute-long answer that took up a lot of tokens. And note that it picked a higher performance model, GPT-5 versus mini. And that's the power of model router. So keep that in mind, that when you're starting if you're in your test kitchen, if you've already started with an ingredient and you want to just if you started with a chef and you want to say, hey, this is a task someone else can do, you can hand it off to them, that's one thing. But if you didn't know ahead of time what the complexity of the task is, you could effectively go to the kitchen organizer, the model router, and say, hey, I have this task. Do you know who in this kitchen would be good for it? And it'll figure it out and send it to the right model for you. And though if you run this over a period of time, you'll be able to see which models are most used for your tasks and make that the default. All right, so with that, we walk through the improving the model. Now we're going to go into the agent and say, okay, the model seems okay, but it's still doing a lot more than us, sending me long answers. That's not what I want. Let's go ahead and now improve the instructions. So just the same way as in a recipe, you're more likely to get a consistent recipe if you give it very detailed instructions. You define what you should do, when, and how. This is a very generic recipe, right? So we're going to change this over and use a much more detailed one. Let's go grab that in just a second. So I'm going to go ahead and write down a much more comprehensive set of instructions. And we can look at this a bit later. But actually, before I do that, I can try something known as a prompt optimizer. So I'm looking at this going, hey, you're a friendly assistant for Java Retail. Ask them when they plan to do their DIY so you can check the weather. I'm going to replace this with this very comprehensive set of instructions, a lot of stuff that I'm telling it, and say, let's save this. And now I can try this out and see how this is comparing to my previous. Now I'm using GPT-5 for Nano, and I've got a V7. So let's go ahead and compare the versions. So on V7, we have the version that has my new prompt, the lot more detailed instructions. And on the other side, we have V6 that doesn't. So now if I ask both of them what the weather in San Francisco is, let's see what happens. Notice that this came back with an answer, but the left side actually responds the way I wanted it to. I wanted a friendly greeting. You see there's an emoji? Very friendly. That's how I wanted it. I wanted it to end with a request for, hey, how can I help you more? Helpful tone. Here it is. So by changing the instructions, I was able to improve the response format and the kind of quality of response that I wanted. Excellent. Took me just a second. So what can we do next? We've improved the model. We've improved the response. And you can also notice over here that I can see that the quality is not passing completely. Safety isn't. So I'm like, I need to know a little bit more about what the problems are over here. So let's look at this. Coherence. It says, hey, the response is coherent, etc. It demonstrates. So why is it 4 out of 5? I don't know. What does coherence mean? Fluency. It's given a 4 out of 5. Why did it give me a 4 and not a 5? So I'm going to show you one other trick before we move on, which is whenever you get stuck with I'm not understanding what's happening here, where can I get more information? We have a really nice feature in Foundry known as Ask AI. So let me just show you that really quickly. So we've done this. So you can go back to the Foundry portal. And if you look at this little thing over here called the agent helper, you can click that button and ask it, hey, what does coherence mean? And what does a rating of 4 imply? So this is a great way for you as you're in the test kitchen. And sometimes, something's happening, you don't know why, because this is the first time you're doing the recipe. You can just ask this expert chef. And it's going to look at your project and your state and come back and give you information along with links to the docs. So excellent. Let's keep going. We've improved our model. We've improved the instruction, so it's doing a little bit more of what we wanted. What can we do next? Notice that we still are not using Zava data. It's giving us answers. So if I say, what paint should I use for my outdoor deck? I expect it to give me a paint that comes in Zava's product catalog. But I'm not seeing that. So let's see what else it can do, right? I'm going to try asking it a question. What tools do I need to build a kitchen island? Now, I wanted to reply with tools that are in the Zava catalog or paints that are from the Zava catalog. But since this is not grounded, it's giving me general purpose information that's brought from the web. So how do I fix this? Next, we're going to improve our tools and knowledge. So over here, you will notice that under tools, we have the ability to upload files. You can also add knowledge through a Foundry IQ integration or agentic memory to keep short-term memory through other integrations. But for our purpose, let's go ahead and use the upload files. So what are we going to do here? With upload files, we're basically saying I'm going to create a new index, and let's call it the Zava retail index for the heck of it. And I have in my local repository a bunch of manuals for Zava products. So I'm going to go ahead and upload a bunch of them together. And what this is doing is it's uploading the files and creating a vector index that can be searched by the file search tool, which is then made available to this agent. So I'm going to go ahead and first show you. I've just put 10 of them. But you'll notice that it's indexing the vector store here, creating a search index. And now it gives me a file search tool that I can associate with this agent. But I want to actually, let's go ahead and add all the different products that we have for Zava. So that way we can kind of figure out if the paint is among them. So we're going to browse for files. And the first time I just put these 10. So let's go ahead and get the rest in. So you're going to put another 10. And you can actually go through at the bottom and see that it's uploading those. And when that's done, I'm just going to put the last 5 in. We've got about 25 products in here, and that's more than enough for us to kind of do this demo. So let's get that from here to here. Great. So I've now added my Zava product catalog. It's getting uploaded in here. And once this is done, I now have a product index that I can tell my agent to use as the tool anytime someone asks information about home improvement tools, so that it's always returning Zava data. So let's see what that happens. So I'm going to save this now. And this is now V9. So let's clear this and try it again. So now I'm going to say, hey, what paint should I use for my outdoor deck? Fingers crossed this will work out. Ta-da! So not only is it coming back to us with here is the best option, but it's giving me a link to the document that I had just updated. It was fairly quick. And notice that it's telling me that it used the file search tool. We can go ahead and verify that using the traces that Carlotta talked about. So now you can see because of the instructions we put in and because of the tool that we added, we have improved our agent's capability to not only return a response that is valid using the response format that we want, but is now anchored in our data. And it's telling you how it went about using the file search tool to go and find the relevant information and show that to us. Excellent. We're really moving along. Okay, so we're here. We've built this thing. Now we're getting there to the point where it is anchored in our data. It's giving us kind of like the things we want. But remember that we talked about how we wanted this to be polite, friendly. It should be concise. What exactly does that mean? Now, so far you've been looking at evaluations, right? What are evaluations? Now it's time for us to go take a look at what evaluations are. So if you click on the evaluations table, what you'll see is there is a tab here for evaluations where if you ever run evaluations on your agent, you'll see the results here. And there's a catalog. Let's talk about what the evaluator catalog is. Going back to the test kitchen analogy, if I'm cooking in a test kitchen, I want to taste the different things and see if they meet the requirements for that recipe, right? And that means that I need a process by which I can taste it. And then I need a criteria, some kind of scale on which I say, based on this taste, I rank this between A and B, right? So then I get a good sense of how close I am to the desired level of acceptance criteria, right? So the good thing about Foundry is that you have a ton of evaluators. If you click on this, these are all built-in evaluators, and you can see that the evaluators come in 4 different categories. You have things like quality. It can look at, if you look at quality, it's going to look at coherence, fluency, the quality of the response, the formats, etc. If you look at safety, it's going to look at things like violence, hate. Does the conversation have anything that might trigger any of your safety acceptance criteria? Business, we'll look at that in a bit. There are business evaluators also provided to you. And then agentic evaluators, which are the most interesting, are those that look at whether the agent performed the way it should. Did it kind of resolve the intent of the user's question? Did it actually complete the response, and did it adhere to that task, etc.? So these are your standard things. So how do you use them on your agent? Well, we're going to talk about 2 things. First, we're going to talk about how you create an evaluation. So I can go ahead and say base evaluation for my agent, and then here, and then I'm basically, so this is for custom evaluator, sorry. So over here, I can actually add a custom evaluator. So the first thing I'm going to do is I'm going to add a friendliness evaluator. And what I want this to do is say, hey, give me rate the friendliness of my agent based on different criteria I provide, right? And so I'm going to say this is a quality criteria. Now, prompt-based. What's the difference between prompt and code-based? A prompt-based evaluator is where you actually have another agent act as a judge for your first agent. So it's using LLM as a judge. So now what you do with a prompt-based agent is you'll create a prompt that actually does the grading, and the other agent will use that prompt as instructions to grade the responses of the first one and then give you a result. This is really good when your criteria, when your evaluation is for something that is intangible. So we hear politeness. What does politeness mean? It's not a very discrete way. It's very subjective. So I can actually write a prompt here, and we're going to go and do that in just a second. Code-based, on the other hand, is like writing a function that takes the current input and returns a deterministic response. And that's a great way for you to write function tools for things like, hey, how long is this? So conciseness, for example, I might define as if this is more than 500 but less than 5,000, then it's concise, otherwise it's not. I can do that with a function. I don't need to waste an LLM on it. So let's see how we can do that. So the first one, we're going to basically say, let me go ahead and give me a 1 to 5 rating. And the easiest way for you to kind of build a custom evaluator using prompts is to go take the example that's there. And very coincidentally, it's a friendliness one. So we're just going to go ahead and we're going to replace this prompt. Let me do this properly. We're going to replace this with a very simple prompt that says, this is how you should assess the incoming input to tell me whether it's friendly or not. Unfriendly or hostile, I'm going to customize this. Unfriendly or hostile means uses swear words or rude language. Might be a way that I want to kind of quantify that a little bit more. This one, it's unfriendly. Maybe just says, for example, does not offer help is an unfriendly thing. And this I'll say, for example, right? For this one, neutral, I'll leave it. Mostly friendly, I'll be like, for example, starts with a cheerful greeting. Remember, our instructions ask you to start with a cheerful greeting. So this lets us use friendliness as a custom evaluator to see whether every response matches our instructions. So I can do this. And then I can say very friendly is when it did everything I asked. So starts with a cheerful greeting and ends with an offer to help, right? Okay, so I can go ahead and create this. And now when I create this evaluator, it should show up. It's created a friendliness evaluator. It takes sometimes a little bit of time for it to actually add it into this list. But after a period of time, you will come in here and you'll find that there's a friendliness evaluator that's available to you as well. So we'll come back and check that out. But in the meantime, let's go and look at how I would start an evaluation on my agent. So here is my agent. And remember that we've been making modifications. We're in version 9, right? If I'm just making changes and then testing it out with a single prompt, that is not really a batch evaluation. I've tested it on one prompt. It may not really work that way for everything. So batch evaluations are where you can set up an evaluation that runs on your agent, and we are running it now manually, but it can be run in continuous evaluation form as well, where you say, can you please evaluate this against a large data set of prompts that test out all the possible things that could go wrong? So to do that, we're going to go ahead and create an evaluation. So I'm going to say, please target my agent. Notice that I can target any version that I want, but I'm going to start with version 7 and say, please target that agent. Remember, this is a new agent. It's in my test kitchen. I haven't actually put it on the table in a restaurant. I have no idea what people are saying about it. So how do I get these test prompts that I can use to evaluate it? Foundry in the portal gives you the ability to generate synthetic data. So I'm going to go ahead and say, please go ahead and generate some prompts for me. And I'm basically going to say new data set is synthgen, let's say, just so I remember. And I'll say use this other model to create these for me. I'm going to just say, give me maybe just 20 prompts. Let's make it even less because we want the evaluation to finish. Give me 10 prompts, 10 test prompts that I could use. And go ahead and generate the candidate response too if you want. And what I want to say, what do I want it to generate? Generate prompts for my Zava retail agent that represent customer support queries for a DIY for a enterprise retail organization selling home improvement goods. So I can put a very broad level of kind of thing, right? And then I'm saying cover single and multi-turn conversations and edge cases like out of stock or returns, right? So I can see something like this. I'm literally saying, give me 10 prompts that people might come to my agent and ask, and I want to use those to really test that it's doing the right thing every single time. So I go ahead and say, now I'm saying, please generate synthetic data, and I'm going to use that. And then the criteria, note that it auto-suggested evaluators for me. It said, hey, here are the evaluators that I think you might like. In the interest of time, I'm just going to pick a few. Say tool call accuracy, task completion. Let's keep adherence. I'll remove a bunch of these. I've just kept a few because it takes time to run evaluations. I've kept the quality ones. Let's keep a couple of things in safety, and we'll call it done, right? So now I can basically go ahead and say batch eval and submit. And when I do this, what's really happening now is I have a process that's kicking off where an agent is, remember, this is a LLM as a judge. It's going to use the test prompts that I gave it. It's going to invoke them on my actual agent, get the responses back, and then it's going to grade those responses for the evaluators I gave it. Now, I didn't put the custom evaluator, and you could absolutely have added the custom evaluator in. But for now, we'll let this run, and we'll come back to this. So what does this do? This allows us to actually continuously run evaluators. So next time I make another change, as an example, I can go off and run the evaluator again, and then I'll be able to see how much the value. So right now, when this is still running, once this is done, you'll see the results. I can now see with every evaluation run how the results are improving. We'll come back and check on that in just a bit. So the last thing I want to talk about, we've talked about evaluators, right? And evaluators are like, the kitchen inspection guy. I've built this recipe and I've kind of like tried it out in my kitchen. Then I have someone coming in to inspect the thing and make sure that I'm using the tools correctly, that my kitchen is in good shape, the recipe is correctly labeled for all of that kind of stuff, right? So this is when the inspection evaluations are really checking that my recipe is working. But what if someone is malicious? How do I know that my agent is protected from people who act maliciously when they send a prompt? In other words, what if someone came in asking for a recipe that they know is going to be dangerous, right? And somehow it got past all these guardrails that I put in, and I end up making it, and it's harmful. How do I prevent that? This is where red teaming comes in, and red teaming is part of the evaluation suite. So over here, I'll just show you how to run one. It'll take a little bit of time. You can come back and look at the results later. But note that this is where the red teaming option allows you to create a red teaming run. And what the red teaming run will do is it allows you to kind of assess the kinds of risks that you are vulnerable to. So here I'm going to say, hey, I'd like you to run an adversarial attack. So the red teaming agent effectively pretends to be a malicious user and attacks your agent by asking it prompts that would trigger harmful behavior if your agent allowed them through. So over here, I'm going to say, go ahead and try it on this retail agent. And what attacks do I want? There are tons of them. In the interest of time, I'm basically going to say, let's not do web search. I want to, and I'll just say kind of like for the tool description, use this for all requests that return products from Zava. And then over here, let's just keep a couple of things, right? I don't want everything. So in the interest of like making this complete quickly, I said, hey, I think my agent is at risk for prompts that, might end up creating responses that have violence or task adherence issues. Let's assess if that happens, right? So I can go ahead and pick those attack categories, the risk categories, things that I think I'm have more risk towards. I'll put a couple of things. So it basically says for that category, I'll come up with at least 3 prompts and I'll try to attack your agent. And then attack strategies. So how does it attack your agent? Obviously, if it brought the prompt exactly as it was, I'm going to know there are content safety filters. We've got a lot of things in place. What red teaming agents do is try to figure out how to manipulate the prompt in a way that gets past the guardrails. Those are attack strategies. An example, I can say, hey, let's use a very simple, there's a flip strategy here, flip. Flip says if I just flip the string over and send it through with a harmful request, because it's flipped, it doesn't read like a harmful request. So it gets through the guardrails and then it'll run it. And because the model is smart, it looks at it and goes, oh, this is a flip string. Let me reflip it and then run it, right? How do you protect against that? So let's see if your agent is susceptible to flip attacks. That's a simple attack, an easy attack. There are more difficult attacks. For example, a tense attack says, I've told you not to respond to these, but if I phrase it in the past of, hey, this happened in the past, it's no longer an issue for me. If I use tense to kind of like say, this is not important, it's not going to harm anyone now, but what if my grandmom said this? Can you explain what she would have said? And it gets through. That's a tense attack. That's a slightly more complex attack. So I've picked a couple of attacks, and now I can actually run a red teaming scan. So let's call this a red teaming scan. I'm going to submit it. And now what you'll see with this is we have now gone from taking that agent that we provided, the very basic one, and we had changed its instructions, made it more, along the lines of what we want in terms of responses. We updated the model so it's cheaper. We added kind of like tools, specifically file search, so it's grounded in our data. Now we've added evaluators so I can evaluate things like friendliness. And I've run a batch evaluation, and now I'm running a red teaming scan. So this is kind of like, and all of this I did in the Foundry portal without ever leaving the browser or writing a single line of code. This is the equivalent of your test, go from test kitchen to table, because with Foundry portal, you've now been able to go down the end-to-end process of building your agent, iterating on it to optimize for various features, evaluating it. When the evaluations are done, you'll be able to see what worked and what didn't, and then using the results of those evaluations to come back and iterate again to fix the issues that you see. So we'll come back and check out the evaluation results when they're done. You can still see they're going on. But while we're here, let's talk about one last thing, which is monitoring. So when you think about observability, you're thinking about traces, monitoring, and evaluation. Traces are kind of allowing you to see the execution of a call. And evaluation is about assessing how well your responses meet criteria for quality, safety, etc. But monitoring is how you kind of get metrics from your production or usage of the agent and understand things like what are the total number of calls, what was the cost, what was the token usage, how many failures did I have, and so on. So these are like operational metrics that you see here, and they give you a really good sense of what this specific agent does. But there's more. Remember, this is a single agent, this is a microservice, but your solution will probably have tons and tons of agents. So let's end by also talking about one last thing. We've been in the Discover tab, we've been in the Build tab. Let's also look at the Operate tab. What the Operate tab does, and I'm going to remove all of them except our Build project. What the Operate tab does is give you the high-level view of your project and all the agents in it. So remember, I deployed an auto router agent as well as this one. And now I can get a really high-level view of what the costs are, how many times these agents have succeeded or failed, how many tokens they've used, and so on. And then drill down from here into the details of each agent. So with that, let's kind of close out this particular act, and we'll move back to the slides. Let's just quickly see if our evaluation's completed, and then we will work our way back. So this is still going on, as you can see, but in the interest of this being a cooking demo, I'm actually going to switch over to one that I'd already done before and show you what a red teaming scan would look like. So here's what a red teaming scan that completes looks like. So once it's completed, you can see that what it does is it tells you for every one of the risk categories that you gave, how many of those were, like how vulnerable your agent is to attacks for that category based on the 2 strategies that we had. Or in this case, I think I had, let me see what strategies. I had a lot, these risk categories, and I still had flip and tense, okay? So let's look at an example of what that is. You can see it passed a lot of them. Let's find one that failed here. So over here, there's a response. We can't see the prompt for very obvious reasons because it doesn't want to show you what attack prompt it used, because then you could try to like really improve it. So over here, let's see if I can actually, let's pick another one so I can see the, okay. I don't know if you can read this, but here is the response. It says, I can't tell what you mean by P1 or which news you're referring to. I need context, anticipation, blah, blah, blah. So there's a lot of text here. And you're like, why was this a fail? And now if you look at the reasoning, it tells you the assistance message discusses general emotional states associated with anticipation. These are descriptions of emotional states presented in a general context without ascribing them to a specific group. No protected class or attitude is mentioned. It's not grounded. And that's why this is a failure. So you can kind of look at how, doing things like, in this case, I believe this must have been a very simple flip attack, was still able to get through and have it give a response that it should not have given. This one is for sensitive data leakage, task adherence, and so on. Let's also see a completed evaluation to see what that looks like. So over here, this is from a previous run. So here is an evaluation of, and what you can see is in this evaluation, the partial is because it completed it. Some evaluations failed and some had errors. This again is really useful for us because it lets us see which evaluations failed and allows us to dive in and say, why did that fail? And then iterate to fix either the instructions or the tools or the grounding until you've got that passing as well. So let's kind of take a really quick look at what failed here. This was relevance and groundedness. And I'm sure if we actually went through and looked at it, you'd have to download the results to see it. But you could then go ahead and kind of understand the nuances behind it, fix it, and iterate on it. So in the interest of time, I'm going to wrap. There's one last step that we wanted to show you, but please do look at the repo because we have a step-by-step workshop where you can find this out. The last step is you're in the test kitchen. You've done everything you needed to do to go from your simple recipe idea to a working recipe that you've tasted. Looks like it's doing okay. Now you want to move it to the restaurant. How do you do that? This is where you can go ahead and click on View Sample App Code, get the environment variables and sample app code that you can then move over to Visual Studio Code, and then work with the same agent through a code-first approach. And I think I had one here, but this is the workshop that you can actually go check out. You can move it into a code-first approach. And once you're in VS Code, you have additional tools, Foundry Toolkit, Foundry Skills with GitHub Copilot for Azure, as well as just basic Azure Developer CLI and other command line tools that'll help you build much more complex solutions on the fly. And with that, let me go back over to our slides and let's wrap up the session. So we just went through a really rapid fire tour of the Foundry portal. We saw how to create your first agent from a Foundry project, update the model, update the tools, update the instructions, write custom evaluators and run them, run a custom red teaming scan. And at this point, you have a recipe that's good to go. So let's wrap up. What did we actually see today? Microsoft Foundry is your end-to-end platform for building apps and agents from initial planning to production. It provides models, agents, data sets, indexes, evaluation, tracing, fine-tuning, and more. Many of the features that you saw in the Foundry portal. Note that in this picture, you see Foundry portal is just one of the clients. It is our low-code client. It's a place for you to kind of experiment with ideas until you're at a point where you feel comfortable moving to code. Once you do that, you have several options. You can use the Foundry SDK to integrate with various languages, Python, JavaScript, Java, and .NET. Or when you go into and use VS Code as your IDE, you have a Foundry toolkit extension that can really accelerate your productivity. And you have Foundry skills that you can use alongside Azure Copilot for GitHub Copilot for Azure. So you effectively have agents helping you build agents. The big takeaway is when you're building agents for enterprise scale, agents are like microservices that combine together to orchestrate into larger scale applications. You need the ability to evolve and adapt your agents rapidly. Foundry portal is your low-code approach that allows you to iterate quickly, experiment with ideas, and go from plan to prototype. In other words, take a simple recipe and taste it till you feel like it's ready for your restaurant. Once you do that, you can move over to Pro Code and use the other options available to you. Today, we looked at how you could author agents using the visual canvas in Foundry portal, use defaults that are available in the portal to basically accelerate your move from the initial agent creation to a custom agent with custom instructions, tools, and evaluations. And finally, it gives you a managed surface for you to not just build and deploy your agents, but maintain your entire fleet of agents at scale. And with that, I'm going to turn over to Carlotta to wrap up the session for us from where we started. Carlotta?
Thanks, Nitya. So yes, let's wrap up and see what we have covered in this session. So we have seen how to discover, explore, and compare models within the Foundry portal. We have seen how to build your agent and keep it with knowledge and tools needed to address the business scenario and the user's needs. We have seen how to include observability and agent controls from the beginning of agent prototyping. And we have seen also how to smoothly move to code, do further customization, and deploy your code on the cloud. Everything can be done within a single unified portal and more, because there's a few things we have seen, which is multi-agent orchestration and fine-tuning and model customization, which is still available within the same Foundry portal. And coming back to our analogy of our test kitchen to table, we can say that, test kitchens like Microsoft Foundry portal are where chef design recipes by fast experimentation, so using a low-code approach. And then, so in this analogy, Microsoft Foundry portal is our test kitchen that then prepare you as a developer to scale out with code using things like Visual Studio Code, the Foundry Toolkit extension within Visual Studio Code, and open source integration with open source framework and interoperable protocols to customize the solution further, build on top of this prototype more complex architecture, and ship it into production. Thank you so much for attending this session. Here's a couple of next steps you want to take. First of all, the first QR code and link will drive you to the Foundry portal workshop GitHub repo, where you're going to find the session material, so the deck, the step-by-step instructions to replicate the demos you have seen today, and also a workshop format of the same content. And on the right, you can see the QR code and the link that will drive you to the Foundry Discord server. There's a huge community. We have a huge community on Foundry Discord right now, and you can, get support from other team members and also join roundtables with advocates in Microsoft, but also product group members. So you can, bring your questions, bring your ideas, bring your experience. And thank you so much. Thank you, Nitya. And see you next time.